Good day, Miss Gasalau here. Today, we're going to talk about one of the most misunderstood topics in chemistry, which is electron configuration. Now, when you search the internet about electron configuration, you will frequently see these things. Pretty confusing, right? But let me tell you this, electron configuration is nothing to be scared of. In fact, once you get the hang out of it, everything will just make sense and you will find writing electron configuration quite fun. But to start, what is electron configuration? Electron configuration represents the arrangement of electrons distributed in the atom. So it basically tells us where are the possible areas that the electron can be found in the atom. And to write electron configuration, we're going to use this guide right here. Now before we start writing electron configuration, let's try to identify first how we can interpret the electron configuration. So in this example, let's have the hydrogen atom. Now hydrogen atom has an atomic number of 1 and it also has 1 electron in its atom. And hydrogen atom's electron configuration is 1s1. So you might be thinking, what does this mean? What does 1s1 trying to tell me? So to know that, let's try to look at the electron configuration closely. So we have here the 1s part, which is called the subshell. So the subshell are the group of electrons in the same orbitals. The first number pertains to the shell or energy level of the atom. The letter represents the orbital where it can be found. And the superscript tells us the number of electrons in the shell. Hydrogen's electron configuration basically tells us that we can find its only 1 electron in the first shell in the s orbital. So that's just how simple it is. If you're still kind of confused, don't worry, we still have many examples and you will have ample amount of practice in writing electron configuration. So like what I have said, we're going to use this guide right here in writing the electron configuration. Now, if you're a newbie in writing electron configuration, this guide is really not guiding us to anywhere at all because it's quite confusing. But we're going to try and learn how to use this guide in writing electron configuration by using this guide right here. So another guide. So we know already that we have a total of 4 orbitals, namely the s orbital, p orbital, d, and f orbitals. Now each orbital could only hold certain amounts of electrons. So the s orbital could only hold a maximum of 2 electrons, p orbital could hold 6 electrons, d orbital could hold 10 electrons, and f orbitals could hold 14 electrons. Now, so you might be thinking, by looking at this guide right here, it doesn't really add up to this guide here. So for you to be able to know how to write electron configuration, we're just going to answer this example. We have here beryllium atom and it has a total of 4 electrons. Now the first thing you need to do is to write the first subshell. Now based from our guide right here, we have 1s as the first subshell. So let's put it here. And then after every subshell, there must be a superscript after it. And we know that the superscript pertains to the number of electrons present in the shell. Now we have a total of 4 electrons in beryllium, but the s orbital could only hold 2 electrons at a maximum. So instead of putting 4 here, we're just going to put 2. So it means that we already identified the location of 2 electrons of beryllium. But the total number of electrons beryllium has is 4. So there is still 2 unknown electrons. So with that, we're going to proceed with the next subshell, which is 2s. So let's write 2s over here. And then after the subshell, we must put the superscript. Now, since we already identified 2 electrons and beryllium only has 4, so it means to say that there's only 2 electrons that is unidentified. And since the s orbital could only hold a maximum of 2 electrons, we're just going to put 2 here. Now, always remember that the sum of all superscripts must always be equal to the number of electrons in the atom. So when we add these 2 superscripts right here, 2 plus 2 will be equal to 4. And it has the same number with the electrons of beryllium. So it means to say that we have correctly identified the electron configuration of beryllium. The electric configuration of beryllium just tells us that beryllium has 2 electrons in its first shell and also 2 electrons in its second shell in the s orbital. Now, it may be confusing for you, but don't worry, like what I have said, we're going to have many examples. So let's try. Write the electron configuration of the given element and then identify the last subshell in the configuration. So let's try writing the electron configuration of fluorine. So fluorine has a total of 9 electrons. By using these guides, kindly write the electron configuration of fluorine. You may pause this video while you write your answer on your papers. Let's check your work. So we'll start by writing the first subshell, which is 1s, and then followed by its superscript. So since the s orbital could only hold 2 electrons, so we're going to write 2 here. And since electrons of fluorine is 9, so there are still 7 electrons that we haven't identified yet. So let's proceed to the next subshell, which is 2s. Now, same condition with the first shell. The s orbital could only hold 2 electrons, so we're going to put 2 as its superscript. So we already identified 4 electrons, so we're missing 5. So let's proceed to the next subshell, which is 2p. Now, p orbitals could hold a maximum of 6 electrons, but we cannot put 6 as its superscript because it will give us a total of 10 electrons already. But we're only looking for 9. So instead of putting 6, we're just simply going to put 5 in here. So like what I have said earlier, all the superscripts must be equal to the number of the electrons in the atom. So when we add the superscripts, 5 plus 2 plus 2 is equal to 9. So it means that we correctly identified the electron configuration of fluorine. Now, the correct last subshell of fluorine is 2p. So let's try and answer the next example. So we have here magnesium atom. So it has an atomic number of 12. Now, based from the guides right here, kindly write the electron configuration of magnesium. You're welcome to pause this video while answering the question. Let's check your work. Your answer must be 1s2, 2s2, 2p6, and 3s2. Magnesium's electron configuration basically tells us that magnesium has 2 electrons in the first shell, 8 electrons in the second shell, and 2 electrons in the third shell. And the last subshell for magnesium is 3s2. Next example. Kindly write the electron configuration for argon. You're welcome to pause this video while answering the question. Let's check your work. Your answer must be 1s2, 2s2, 2p6, 3s2, and 3p6. Argon's electron configuration basically tells us that argon has 2 electrons in the first shell, 8 electrons in the second shell, and also 8 electrons in the third shell. And the last subshell of argon is 3p. Next example. So we have here nickel atom. Its atomic number is 28. So make use of the guides right here and answer the question, what is the electron configuration of nickel and what is the last subshell? You're welcome to pause this video while answering the question. Let's check your work. Your answer must be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d8. Nickel's electron configuration basically tells us that it has 2 electrons in the first shell, 8 electrons in the second shell, 16 electrons on the third shell, and 2 electrons in its outermost shell. And the last subshell for nickel is 3d8. Now that is the last example that we have. Always remember, the electron configuration shows the sequence of how electrons are arranged in an atom. The first number represents the shell, the letter represents the orbital, and the superscript or the second number represents the number of electrons found on the specific shell. And lastly, electron configuration can be used to show how many electrons are there in each shell. If you still have any questions or clarifications, you may contact your science teacher. Thank you so much for watching, and remember to never stop learning. Once again, this is Miss Gasalao. See you in the next video.